Hey everybody, welcome to this talk on build and deploy an Alexa chatbot and convert it to an Alexa skill. My name is Sohan Maheshwar and I'm a developer advocate for AWS working in the Benelux region. So let's dive straight in. I'm so excited to be here today to talk to you about conversational interfaces, and that's what the focus of today's talk will be. We will talk a bit about Amazon Lex and the technology behind it, how it works, and what you need to do to build a Lex chatbot. We will talk a little bit about a few concepts related to chatbots like intents, utterances, and slots. We will talk a little bit about Amazon Alexa and how it is the next major disruption in computing, and then we'll end with a small demo. So let's dive straight in. Now, I'm sure all of you have, in some capacity or the other, worked with personal computing, or else you probably wouldn't be watching this talk today. And all of the personal computing that we have interacted with so far has looked like what you're looking at on the screen right now. It's been either a mobile phone or a laptop or desktop computer, or you could even have interacted with a thermostat or a remote control or a car entertainment system. Now, if you really notice, the interfaces on all of these have sort of been similar. And to give you a small history lesson on interfaces, well, it all started in the 70s when you had these small black and white monitors like the one that you see on the screen, and you had just this keyboard and you entered text-based commands to do something. Things evolved a little bit a little later on in the mid 80s when for the first time you had graphical user interfaces. So you could actually see a file on the desktop and you could move this piece of hardware around that would translate onto the screen. And I'm talking about a computer mouse. And things evolved a lot more, in the 2000s when for the first time you had touch screens in your pocket. And that was mind blowing back then. You had this amazing device that could be in your pocket that could give access to the wealth of the information in the world, and you could use a touch screen. So you could zoom by doing that pinch to zoom, and all of these are interactions we have on a day-to-day basis. But guess what? These interactions and these interfaces are interfaces that we have actually learned over a period of time. It's not like any of these interactions really came naturally to us, but we learned it to be able to talk or to be able to communicate with computing. But thanks to all the advancements in tech, especially in the field of machine learning and speech recognition and natural language understanding, we are at a stage now where we can actually communicate with computing via conversation. And we call these conversational interfaces. Now, conversational interfaces are set to sort of change how we think and operate and behave. Because for the first time, as humans, we can actually communicate by chatting or talking, and which was obviously not possible earlier. And this topic is very dear to me because I worked in the Alexa team for over 2 years before now I'm working in the AWS team. So it's I've worked very closely in that team, and I sort of know the cutting edge technology that really goes into this. One thing I should always say is that this paradigm really excites me because I think it lowers the barrier to access technology. Right now, I'm sure we've all gone through this phase where we've helped either a parent or a grandparent or an elderly person with tech, and usually the conversation goes something like this, where you say, hey, click this, do this, swipe here, and this is what would happen. You're sort of teaching them a series of steps to do something. But with conversation interfaces, all they need to know is to sort of know the language, and they'll be able to access technology that would have probably been a little difficult earlier. When it comes to conversational access in tech, I think the most important tenet is for it to be natural. We as humans have to be able to speak naturally, and it's the job of the computer to really understand what's going on. And it's the job of you as a developer or a technologist to design the chatbot or to design the Alexa experience in such a way that it's the skill or the chatbot's able to understand what the human is really saying. Now, a line I often use is that I think so far we as humans have been forced to think like computers. We shouldn't be thinking in terms of drop-down menus and radio buttons, but that's how we've interacted with our tech. But with conversational interfaces, I think computers are being forced to think like humans, and which I think is very powerful. You also want your conversational access to be on demand, especially in cases like customer support or informational chatbots. You want it to be on demand. You don't want it to be like, say, email, where you send an email, you wait for 2 to 4 days for a response back. Conversation allows that instant sort of transfer of information that you really want. You also, of course, want it to be accessible. So you don't want it to just be on, say, a platform or a website where you need like 5 levels of access to get to. You need it to be where the people really are. And I think all of this entails in the fact that it has to be efficient. It has to be efficient from a tech point of view and from a design point of view as well. So Amazon Lex is a service that Amazon has built for building conversational interfaces using voice and text. And we will talk a little bit about how Lex works, its benefits, its features, and we'll talk a little bit about how you can actually build something using Amazon Lex. Amazon Lex basically offers the complete solution when it comes to building a conversational interface. So you don't need to have a machine learning background to be into speech recognition or natural language processing. All you need to know is to know a little code so that you can build a really nice conversational experience. So Lex takes care of things like speech to text and speech recognition and so on, and also the dialogue management. You can actually deploy it to different places, and we'll talk a bit about that in a while. Lex is completely scalable and connects to a whole bunch of AWS technologies as well. So you don't have to worry about, catering to one user versus a million users. It has a lot of security services that it works with. So you don't have to worry about things like personalization or even authentication. And of course, you get great analytics about how people are actually chatting or how people are talking to your interface or your chatbot. So you can really iterate on, making it a lot better. So let's go into some of the features of Lex. And I think the one of the best features is the fact that you can build this chatbot just once, write the logic of how the front end and the back end works. And again, we'll talk about that later. And you can deploy it to multiple platforms. So you can deploy it to mobile, you can deploy it to web, also popular messaging platforms like Slack and Facebook and Kik and Twilio SMS as well. And the demo is going to show you just that. Lex is, of course, designed for builders. It's efficient, it's intuitive. In fact, very recently, the Flemish government actually built a chatbot using Lex to answer questions from their citizens about the COVID-19 situation. So, as you can see, it's designed for builders. You can really use it to build scalable chatbots very quickly. Also, Lex is enterprise ready. So if you have a bunch of SaaS tools that you want connected, maybe you want a chatbot that's internal that just connects to sort of metrics within your organization, or maybe it is something to help new joinees in your organization. It can automatically connect. I mean, you'll have to connect it, of course, but it has options to connect it to other SaaS systems as well. And of course, there is continuous learning. So as more people use the chatbot and more people use this experience that you've built, the better it gets. So over time, you can make a really, really powerful chatbot that really understands your customers really well. All right. So that was about why you need to think about using Lex. So let's talk a little bit about the design workflow and how Lex actually works. So on one side, you have your customers. Your customers could be on mobile, they could be on the web, maybe it's via IoT, or they could be on any popular messaging platform such as Twilio and Kik and Slack. Now, when they use a Lex chatbot, few things happen. One is, as a developer, you can actually choose whether you want to authenticate them before they start the bot. Now, sometimes you may want to authenticate them, especially if there is an account associated with what information they're trying to get. But a lot of informational chatbots don't need authentication, so this is something that you can absolutely choose to do. Cognito is an Amazon service that actually takes care of a lot of this authentication and identity. So you can use Cognito to authenticate your users. You can even use CloudWatch to get metrics on how people are actually using your chatbot. Now, here comes the interesting part. So when someone talks to your chatbot, Lex basically uses two technologies, both of which are based on the same deep learning that powers Amazon Alexa. The first one is if your user uses speech to talk, then there is something called speech recognition or automatic speech recognition, ASR, which converts speech to text. Now, it just doesn't convert speech to text, but it does so with a lot of context, because when it comes to speech, two words can sort of sound the same. So you really sort of need contextual speech recognition to make your speech recognition that much more accurate. Once you've converted that speech to text, or if someone speaks to your chatbot only via text, how does the bot actually understand what you've said? The bedrock of all conversation interfaces, right? Chatbot and Alexa and what have you, is something called natural language understanding. Now, this is a pretty popular field in computer science right now because it really sort of drives the whole conversational experience home. So, what natural language understanding does, and this is really simplifying it, is it converts unstructured conversational data. Human conversation is not structured, there is grammar, but it's unstructured. It converts that into a structure that computers can understand. How it does that is it converts like a sentence that I say, or an utterance as we call it, into a bunch of things called intents and slots. And we'll get to that in a bit. So what happens is Lex uses this NLU, natural language understanding, to convert what the user said into a structure, which is what the intent is, what the slots are, and that is sent to a place to fulfill whatever service you're providing. So typically that is a Lambda function. This is your backend essentially. Your backend, you can choose what you want to do with it. You can hit an API, you can hard code some data, you can query a database. All you have to do is send some structured data back, and takes care of showing the output back to the user on the platform that they have chosen to interact with you. So that was the workflow behind how a chatbot actually works. Now, let's take a closer look into a couple of terms that I actually mentioned earlier, which was what is an intent, what is an utterance, and what are slots. So for the purpose of this presentation and the demo, I built a simple ordering flowers bot. I'm based out of Amsterdam and it's tulip season here. So the tulips are blooming all over the city. So I built a simple bot that simulates a conversation where a user or a customer wants to order flowers. So here's how the conversation between the customer and the bot goes. So the customer finds the bot and says something like, I would like to buy flowers. Now, let me break this down. What the customer says is essentially what an utterance is. Now, the thing with conversational interfaces is that a customer can say the same thing in many different ways. A customer could say something like, I would like to buy flowers. I want to buy some flowers. Hey, can you help me buy some flowers? Hey, can you help me purchase some flowers? So there's so many different ways of saying the same thing. To give you another example, something as simple as asking for the weather. A customer can say anything from what's the weather, tell me the weather, to is it hot outside, or do I need a coat today? Just different ways of saying the same thing. Now, in any conversational interface, all these different utterances are matched to something called an intent. An intent basically performs an action that is a response to any utterance. Why do you really need this intent? Well, like I said, there are so many different ways of saying the same thing. So every utterance has to be mapped to something called an intent. All right. So a customer said, I would like to buy flowers. The bot responds with, hey, what type of flowers would you like to order? The customer says tulips. And the bot responds and continues the conversation with, hey, what day do you want the tulips to be picked on? What time? Can you confirm? So on and so forth. You'll see here that the chatbot is actually asking for certain pieces of information. I've underlined tulips there. Tulip is the type of flower. A user could say something like rose or lily. And similarly, the bot is also asking for the day and the time at which they want the flowers to be delivered. These pieces of information are called slots. And think of slots as variables within an utterance. Any piece of data that can change from user to user within an utterance. For example, going back to the weather example that I spoke about, I could ask for the weather in Amsterdam, but someone could ask for the weather in Paris or in Delhi or in New York. So in that case, the city there, Paris, Delhi, Amsterdam, etc., becomes the slot. And the slot value becomes what I just mentioned. So that is what a slot really is. You'll also see rather that this is how the conversation would typically end, where the bot says something like, hey, your tulips will be ready for pickup at 9 a.m. Is that correct? And the user says yes. And the bot says, thank you, your order is placed. And there's a nice little emoji there as well. So this is what we call the fulfillment, where after all of this conversation, your backend is sort of fulfilling the user's request. And again, your backend could typically be a Lambda function. which talks to your services that you've already built in your startup or your enterprise. All right. So the core of any of the conversational experience is basically the entire how the conversation is handled and how the dialogue is handled. So we have something we call slot elicitation, which is basically how Lex asks for pieces of information. Now, for something like the flower delivery bot to work, it needs few pieces of information. It needs what type of flower, it needs the city, the date, and the time. These four pieces of information it absolutely needs. Now, you would hope that all your users and all your customers would talk like this, where your bot says something like, "Hey, what type of flower do you want?" And the customer says, "I would like tulips that I can pick up tomorrow in Amsterdam at 9 a.m." So in one shot, they're giving you all four pieces of information, which is great. But unfortunately, or fortunately, this is not how we talk or how we communicate as humans. Imagine if you were to call up your local flower seller and they say, "Hey, what flowers do you want?" Or, "Hey, how can I help you?" You won't give them all these pieces of information in one shot. Typically, there is a back and forth between the user and the person providing the service. So we've modeled, or we've given the option to model a similar sort of paradigm with the bot as well. So in this case, you can see the bot is asking question like, "Hey, what type of flowers would you like? What day do you want it? What time of day?" and so on. So essentially what's happening is what we call slot elicitation, where the bot is basically asking the user for the pieces of information it needs to complete that request. And it's doing so by using something we call a prompt, which is basically a spoken or a typed phrase that invokes this intent or that gets that piece of information. Like I said, the core of providing a great conversational experience is managing this dialogue. Now, what you saw earlier is what we call a multi-turn dialogue, where there is different turns between the user and the bot. The bot says something, the user responds. The bot says something, the user responds. Uh, the other way of actually talking is what we call a single turn conversation, where the bot says something, the user says something, and the conversation is done. Most conversations that we've seen are actually multi-turn conversations, and these lead to better user experiences and happier customers. So Lex takes care of this multi-turn conversation and what we call dialogue management. So as you can see, there are a few types of slots. There's the type of flower, there's a pickup date and a pickup time. And each of these slots has corresponding prompts as well. So if a user doesn't mention the type of flower, the Lex bot will remind them saying, "Hey, what type of flower would you like?" Or if they don't mention the date or the time, the corresponding prompt will be, "Hey, what time would you like the flower to be picked up?" The great thing about this is it's not completely linear as well. So suppose a user says something like, "I would like the tulips to be picked up tomorrow at 9 a.m." The users answer two questions there, right? So the next question by the bot is not again going to be, "Hey, what time should we pick up the tulip?" Because the users already answered that question. So there is enough intelligence there for that dialogue to be managed and for each of those slot values to be picked up. All right. So we're going to be talking a little bit about how you can customize conversations. Now, conversations are not easy if you really think about it. As humans, it comes naturally to us, but for a computer to mimic a conversation, it's not as easy. And the reason is, I think, because conversation and we as humans, what we do really well is hold context. We hold context amazingly well. I can meet an old friend of mine and refer to some good times we had, like maybe 10 years in the past, and that reference is immediately picked up by the person because both of us have that shared context. So we've tried to give that sort of contextualization to Lex and to bots being built on Lex as well. And having that sort of contextualization and personalization is the key to building a good conversational experience. So, for instance, if a user says something like, "I would like to buy flowers," and they have been doing that over the past week, the bot's next response could be, "Hey, would you prefer to buy tulips again?" So you're giving an added contextualization to that particular user. There's a good chance if a user has bought tulips on 4 consecutive days and they use the bot for the fifth day, they're probably going to buy tulips again. So, which is why we've given you that option to actually do that. Similarly, you can also validate the user's input again if you want. So maybe you don't have tulips available on the day that the user has asked again. You can say, "Hey, sorry, I don't have availability. would a later day actually work for you? Like I said, conversation is not easy, and you need context, and you need to sometimes store that context to have a nice conversational experience with the bot. So for that, we've given the option of storing something called a session attribute. Now, a session attribute is some piece of data that helps with storing context. This could be context of a session. A session is defined from when a user starts using the bot to stopping. So maybe the user logs in and says, hey, I need help with my order. This is my reference number. And that reference number is stored as a session attribute. So till the bot actually helps the user, that reference number is stored. Sometimes session attributes can be permanent as well. Maybe this is a bot which requires some sort of login and authentication, and the user logs in. So then you maybe know the user's name. So you can store the user's name in a session attribute so that the next time the user logs in, you can welcome them with a hey, like a welcome back, Sohan, which sort of gives you that nice user experience at the end of the day. As you can see, Lex sort of maintains this context by storing data throughout a conversation. This data could be anything from a slot value to, like a confirmation, and all these are actually stored in session attributes. And we give you, the developer, the flexibility in figuring out what to do with these session attributes. Now, conversation is not always linear. All right. If conversations were always linear, they'd be boring, but they'd be easier to maybe build for when you're building a chatbot. So typically, a conversation with a chatbot could go one way. So if you were building, or rather, if you were building a bot that helped with buying flowers, maybe the user is almost done with the entire process. At the end, the bot says something like, would you like a small or a large bouquet? Now, at this point, the user doesn't know how many flowers are there in a small bouquet, like how small is small or how large is large. So the user says something like, how many flowers in a large bouquet? This is a different intent at this point of time. When a user says something like this would match to a whole new intent. It wouldn't be part of the order of flowers intent that we spoke about earlier. So in this case, you have to switch contexts and store the current context in a session attribute and answer the user's question. So maybe you say, hey, 30 flowers in a large bouquet. Then if the user says something like, oh, great, place my order or confirm, if you've stored the context in the session attributes, you don't have to ask the previous questions again because that context is really maintained. And again, Lex gives you that option to do so. So this way you can switch seamlessly between intents and come back and not have a bad experience for your user. If you didn't store the session attributes there and the user asked a question like, how many flowers in a large bouquet? Your bot answers saying, hey, 30 flowers in a large bouquet. And then when they came back, you'll have to go through the entire process again, which is not a good look. So you need to store that session attributes when you're switching contexts. You can also chain different intents together sometimes. So for instance, say a user has gone through the entire flow to buy flowers, and the bot says something like, hey, anything else today? And the user says, hey, you know what, I want to update my address. This is for someone else. And you can actually chain the update address with the order flowers address and have a seamless conversation so that the user doesn't feel very confused. This also leads to a good user experience and gives you flexibility as a developer as well. All right. So when it comes to specifically text bots on Lex, you can take advantage of the medium. It's always good to really take advantage of the medium and to use rich message formatting. So for instance, there will be a lot of times when you actually want to show visual feedback to your users. For instance, this is an example from a car rental bot where a user is looking at three cars before they choose which one they want to rent. Maybe a user is buying t-shirts via your amazing chatbot and they want to look at like the three different colors that you offer before they actually place the order. So you can take advantage of the rich messaging formats on different platforms to give a better experience for your user. Now, each platform has its own way of sort of figuring out formatting. So Slack versus Facebook versus Kik will look different. Similarly, you can really customize the experiences on your mobile app and on your web app as well. But make sure you use the medium well to provide like a good experience for your user. When it comes to the fulfillment of what your chatbot's doing, there are a couple of ways you can do it. Most people will choose to use a Lambda instance. So again, there is a call that's made to your Lambda function, and you can choose what you want to do with it. Maybe you make an API call, maybe you hit a database, you can hard code some data. It's really up to you, and your Lambda will return whatever text that your user is choosing to see. A lot of times, you can return that to client as well, so the output can be returned to the client for further processing too. And a lot of times the dialogue part is sort of taken care of by Alexa. So until the slots are elicited, all the prompts are thrown in, and then the fulfillment is made to your Lambda function. Like I said, Lex takes care of the entire life cycle of the the chatbot. So you can actually save your bot, and it preserves the current state on the server. You can build your bot, which sort of builds the binary, and you can build like test, dev, and prod versions as well. And you can test it out right in the Lex window. And once you think it's ready, you can publish it out to different platforms. You can publish it out to the messaging platforms as well as mobile and web. I think one of the greatest things about just using chatbots is the fact that you can implement continuous learning on the chatbot. This helps a lot, especially in the cases of things like customer service bots. Just to give you an example, most customer service clients, I mean, not just bots, but if you take even like a call center, 80% of their queries are, 70 to 80% of their queries are from the same bank of questions or queries, right? Typically, customers have the same bunch of queries. With a chatbot, there could be one that's outside of those usual queries. And at that point of time, you can choose to maybe switch to a human at the back end, where you're really augmenting this experience with the human. The human answers the question, and that question and answer is again fed back into your system. So the next time someone actually asks that question, the bot is answering the question, and that process is becoming a lot more efficient over time. You can also use CloudWatch to monitor your metrics. So, you can get really good metrics about how people are using your bot, when they're using it, what are the intents that are being hit the most, what are the responses you're getting the most, and so on. And another thing you can also do is sort of manually look at the utterances that were missed. And this brings us to an important point about conversation interfaces, is that testing becomes so much more important for all the artificial intelligence in testing and automating your testing. When it comes to conversational interfaces, you really want to look at a lot of beta testing and manual testing for your bot. The reason is you might have thought of maybe 10 different ways someone could say a certain thing, but there could be a legitimate 11th way of saying something. So you really want to look at your missed utterances to see and to make your bot that much more understanding and that much more efficient. Like we mentioned earlier, Lex is multi-platform. So you can build that one bot just the one time, and you can deploy it to a mobile app. You can deploy it to Android, iOS, all of that. You can deploy it to a host of messaging platforms, namely Slack, Kik, Facebook Messenger, and Twilio SMS as well. You can deploy it on the web using all the commonly used web SDKs like React and JavaScript and Python and so on. And you can also integrate with AWS IoT. With use cases, and I'm sure you already have amazing ideas of how you can implement Lex in your organization or your startup. But right now, we're seeing a lot of popularity in contact center and informational bots. And these are extremely popular, and they help make the system so much more efficient, especially when it comes to things like asking for information. When you have a lot of information on your website, sometimes a bot is just that much easier. You can also use it to build applications. I know of people who have built great bots, even in things like their DevOps. So it's contributing to enterprise productivity. And like we mentioned earlier, you can also integrate with AWS IoT. So you can build IoT bots as well. All right. Like I mentioned earlier, I worked for more than 2 years in the Alexa team, and it was an exciting time for me. I want to talk a bit about Amazon Alexa, how it ties into this, and then show you the demo. So Alexa, in case you don't know, and I'm guessing a lot of you watching this right now have a device at home. But for those of you who don't know, Alexa is the cloud-based service that powers devices such as the Amazon Echo, which you see on the screen. Now, these devices that you see are very, very powerful in the sense that they each have a microphone array. So you can get far field recognition. So I can speak to a device like almost 20 feet away. And these devices really help with, like everything from day to day to entertainment, to weather, to news, to music, and there's so much more. And the real vision for Alexa is this whole Alexa everywhere sort of vision where people are interacting using their voice because it's such a natural interface, not just at their home, but also on the go, at their workplace, in their car, and so on. Now, when it comes to Alexa, there is something called a skill on Alexa. Think of it as similar to how the mobile ecosystem has apps. Alexa has skills. So anybody can build a voice-based experience. It's called an Alexa skill and upload it to the skill store. Right now, there are 100,000 plus skills worldwide, and that number is just growing. And like you can see, most of the big brands in the world have amazing Alexa skills that they are published so that users can use them. The skill store is very popular, and anybody can build a skill for free and upload it to the skill store. So I'll also show you a demo of how you could do that. So once you build a Lex bot, it's actually fairly simple to take the front end of that Lex bot. So I'm talking about the intents, the utterances, and the slots and the prompts. There is an option to export that. So just hit the export button and make sure you choose Alexa Skills Kit. This is a framework basically to build a skill. So make sure you choose Alexa Skills Kit as a platform before exporting your bot. Once you've done that, you can go to developer.amazon.com and create a new skill. It would ask you a few pieces of information like the name of your skill and what language model, because it's there in multiple languages like German and French and Italian, etc. So it would ask you that. And then, as you can see, there is a drag and drop JSON option. So you just drag and drop that file that you've just downloaded, and it sort of builds the front end for the Alexa skill for you from the bot that you've created in Lex earlier. All right, so let's do a quick demo on how Lex actually works, how you actually build the front end for your skill, how you deploy it to a web UI, and then to a messaging platform, and then export that to a JSON file, which you can import to an Alexa skill. So I've just built the simple chatbot here. And as you can see, this is a simple bot that has just the one intent, which is web UI order flowers. Now, every intent has a bunch of utterances associated with it. These are utterances that you as a developer have to add. Essentially, you sort of put yourself in your customer's shoes and think, okay, what are the different ways they could, in this case, ask to buy flowers? And as you can see, there's a fairly comprehensive list of different ways to buy flowers. There's everything from may I get flowers to I want to order flowers, I want to buy flowers, I want to put in an order, just different ways of saying the same thing. All of these utterances really map to this particular intent that you see here. Now, we also had slot values in this particular chatbot, and there were three specific slot values: the type of flower, the pickup date, and the pickup time. Now, as you can see, the flower type is the first slot, and the slot type is something that I have defined on my own. It's what I call a custom slot type, and I've called it the web UI flower type. What you can do is there are two types of slots. There's a custom slot type when it's a data set that is custom to your particular chatbot. In this case, I can limit the values of that slot to maybe the types of flowers that I sell. And you can also add validations. So for example, a customer asks for hydrangea and the seller doesn't sell that. I can throw in like an error saying, hey, you know what, I don't sell that, but these are the types of flowers that I actually sell. Every slot is associated with a prompt as well. You can see the prompt which says, what type of flowers would you like to order? So if a customer doesn't mention the type of flower that they want, the bot actually throws that particular prompt and says, hey, what type of flower would you like to order? Now, the other two slots are pickup date and pickup time. And you will notice that both of them start with Amazon dot. These are essentially built-in slot types, which are slot types provided by Amazon for you to build your bots easier. Now, these slot types are well tested, they're very comprehensive, and they exist for a lot of the common data sets that you might use while building a bot. So things like date, time, currency, city names, place names, and so on. The two built-in slot types as well have their corresponding prompts. So you have what day do you want the flower type to be picked up? And you'll notice that we have referenced another slot within the prompt, which is something that you absolutely can do. You will also see here that there is something called a confirmation prompt, which is something that you see at the end of whether or not you've or at the end of the process. So once the bot has got the pieces of information, uh, the bot will actually confirm saying, hey, is this what you wanted? Do you confirm? This is a good practice to have when you're actually asking for a lot of pieces of information from your user. If it's just a one shot, then probably not a good idea to have that. All right, so now we're going to actually publish the bot. I can choose the alias and I can actually publish this bot. I can choose where I want to publish it to as well. I can choose to publish it to either web or mobile, or I can go to all the different channels that Lex has connections to, which is namely Kik, Facebook, Slack, and Twilio SMS. Now, publishing it to these channels is very simple. You have to create an app or a bot on those platforms and then just enter some details like a client ID, a verification token, and a couple of other details, which just links the two together. So in this case, I've created an app on Slack and I have published this bot to Slack as well. So first, let's see how the bot works on the UI framework that I've built. Here is the bot. And as you can see, there is a chat window here. So I'm just going to chat with it and say, I want to buy flowers. There is the rich messaging type that we spoke about. So there's a photo of some flowers, and I'm going to click on the tulips button. So what day do you want the tulips to be picked up? The great thing about this conversational experience is I don't have to just enter like a date in a DDMMYY format. I can specify a date, or I can even say 2 days from now or tomorrow. So for now though, I'm just going to say June 20th. Okay, it asks me for what time. I say 10 a.m. and there's a confirmation prompt. So I say, yeah, sure, let's do it. Thanks for your order. And it was literally that easy. Of course, this goes to your Lambda as a structured JSON, and your Lambda does the part where it fulfills this order. It maybe talks to your API and so on. Now I've done the same on a Slack channel as well. I've added the app order flowers, which is of course a bot, and I can have the same conversation here. So I'm going to say buy flowers. And as you can see, it is the buttons are native to how it would look on Slack. If I gave you this demo on Facebook Messenger, it would look native to how it would look on Facebook Messenger. And Lex actually takes care of all of this, which is another plus point about why you should use Lex. So I'm just going to click on Tulips. It says what date. I say June 20th. Okay. I say 10 a.m. Looks like there's going to be a lot of flower orders on June 20th. And I say yes. And this is done. So this was an example of the web UI and on Slack. Now I'm going back to my bot. And yeah, this is where all the bots that you created would be listed. And if I just choose that and click on actions, there is an option to actually export this bot. So I'm going to click on that, choose the version. When it comes to platform, make sure you check Alexa Skills Kit. This is the framework on which you need to use to build Alexa skills. So you can actually export the front end of your bot, which is the utterances, the intents, the prompts, etc., as a JSON file, which you can import into your Alexa skill. So I'm just going to export this. And this gives you a downloadable, which is a zip file. I can just download that. You can then go to developer.amazon.com and create a skill. You have to enter a skill name and what we call a skill invocation name, which is the phrase a user says to start talking to your skill. So for a customer to start talking to our skill, they have to say, open order flowers. In the JSON editor pane, I can just drag and drop that same JSON file, which basically gives you a JSON representation of all that we built earlier. So as you can see, all the sample utterances are here. Our slot types and our prompts are here as well. So it's essentially just a simple JSON file that I've imported to Alexa, which makes it so easy to start building. I'm just going to click on save and build model, which actually builds and trains the model as you go. Now, with Alexa, I recommend building a separate backend in the sense you build a different Lambda function. Alexa gives you the option to host your own Lambda function within your skill itself. So the code option you see here is precisely for that. It's basically a Lambda function that is just for the skill. And you have the ability to to test your skill in the browser as well. So even if you don't have a device, you can test your skill in the browser, which is what we're going to do as soon as our skill is built. It has. So I'm just going to build the skill now. Yep, there we go. I can use my voice or text, but I'm just going to use my voice. Open order flowers and buy flowers.
What type of flowers would you like to order?
Tulips.
What day do you want the tulips to be picked up?
June 20th,
Pick up the tulips at what time on the 20th of June 2020?
10 a.m.
Okay, your tulips will be ready for pickup by 10 o'clock on the 20th of June 2020. Does this sound okay?
Yes.
Thanks for using order flowers.
And that was it. So as you can see, we used the same bot that we built on Lex, and we exported that bot and we imported it to Alexa to start building the skill. Of course, I have built my own backend for the skill, but it's a great way to sort of convert that Lex bot that you've been building into an Alexa skill. So you saw in the demo how we built this one chatbot on Lex. We deployed it to a web page, we deployed it to Slack, and then we used the JSON file from the Lex bot, and we exported it into an Alexa into Alexa skill to build an Alexa skill out. Of course, for this demo, I built two different backends for the Alexa skill and the Lex bot. Now, theoretically, you can use the same backend, but it becomes a little easier if you actually have two separate backends for the two, because the main difference between building a Lexbot and an Alexa skill is that with a Lexbot, you actually get access to full transcriptions of what the user said. But with an Alexa skill, all you get is the intents, the slots, and so on. You actually don't get the entire transcription of what the user said. So there is that slight subtle difference, which probably makes it more practical for you to have two different Lambda instances for your Lex chatbot and your Alexa skill. The one thing to really keep in mind while building a chatbot and then building the same conversational experience on Alexa is that there is a certain difference in designing for text versus designing for voice. And this is purely a design conversation we're having right now. So just to show you and illustrate those differences, when you're designing a chatbot, you're sort of designed for reading and writing. You're designed for people to be reading something, and whereas for Alexa, you're designed for people to be listening to it and for speaking out loud, and that makes a huge difference. Just to give you an example, take the differences between how the Harry Potter books read when you're reading the book versus actually looking at the film. You'll see big differences in the dialogues that are spoken out, because one, you're actually reading out, rather reading, and the other you're actually listening to. So make sure you keep that in mind while designing for the two. When it comes to text and a chatbot, you can personalize your brand by the use of rich messages and emojis. You saw that we used a nice flower emoji when the order was complete, and we also used rich messaging, which, of course, with voice you can do in different ways. You can use something called speech cons, which are basically things like sound effects or words that are common to a certain area that you hear a lot, like hurrah or congratulations and things like that. Alexa gives you the option of using these phrases and to make it sound that much more interesting. You also get access to a huge sound library on Alexa that you can actually use, as you saw in the demo that we created. Like I said earlier, designing for reading and writing means that people have the ability to skim read. I think we've all read textbooks, especially when there's a lot of text, where we are able to skim read and just pick out the piece of information that we want. So when you're building a Lex experience, it's okay to be a little more informational so that people can pick out the things that they really ask you for. When it comes to voice, it's not quite the same. People don't have the or we don't have the option to sort of skip through what Alexa is saying. So try and be as brief as possible, and this is imperative. In fact, in the Alexa team, we used to say the thumb rule was the one breath rule. If it takes longer than one breath to say that entire sentence out, it means it's too long. So keep it as brief as possible. And lastly, and this is very subtle, but when presenting choices with something like Lex in text, basically, you can present multiple options just fine. So you can say something like, hey, would you like fries or salad? And people would reply with either of the two. In voice, though, make sure those choices are definite, because saying something like, hey, would you like fries or salad, informally especially, and we often hear the response to that is yes, because people don't know if that is a choice in itself or they have to choose between the two. So make sure you have very definitive choices like, hey, which one would you like, fries or salad? These were the subtle differences between designing for text versus designing for voice. I think keeping in mind some of these differences actually leads to really strong experiences that your customers will come back to. And it is all about building such engaging experiences. So keep that in mind while you're actually building it out. And that was it for my talk. So, first of all, thank you so much for attending this conference. It is a virtual summit, of course, but do check out the Discovery Zone. We have some machine learning competency partners like Accenture, Deloitte, and Snowflake. So, go have a chat with them, see maybe if you can work with them and get to learn something as well. I had a great time doing this. Thank you so much. I would love to hear the sort of conversational experiences you are building. So hit me up on Twitter. That's my Twitter handle right there. And I'd love to hear from you. Thanks again, and bye.